All right. So, homework 6.
You watched The Walking Dead?
I haven't. I've had several people tell me I should, but
Pretty good.
I haven't actually started watching it yet.
I get into the wrong season.
Let's see. All right. So, homework 6 is all about confidence intervals. Basically, it's kind of an application of what we did in the last homework. It's like the idea is if you know the mean and the standard deviation for a population, and then you take a sample, say size n, can I find an interval, which interval means exactly the same thing it does in algebra. It's like bigger than the bottom number, smaller than the top number. So can I find an interval that whatever percent, I'm just going to say 95 for the grins of it, but it could be whatever percent you want, certain that the sample mean will be in. Which, in real life, I mean, this is interesting, but the next homework we'll do hypothesis testing, which is the other way around. In real life, we tend to not know this population and this population mean and standard deviation. What we know is the sample mean and sample standard deviation. So the next homework is going to be, hey, how do you start with the sample data and make conclusions about the population? But for this homework, we're going to say, okay, pretend like we know the population, and then we're going to get stuff about the sample. All right? And it's really, really simple. So it's probably easier to go by example than it would be. Well, okay, let's make up something silly. There was a lot of IQ scores, right? Let's go with IQ scores. Let's say the mean is 100, standard deviation is 20, and I take a sample size, let's make it 49, that way square root will turn out even. All right. So everybody happy with the setup? Okay, we know from the central limit theorem that the mean of all the sample means should also be 100. Right? And we know that the standard deviation of all possible sample means should be 20 over square root of 49, which is 20 over 7. Right? Okay. So if we want to say, okay, find an interval that I'm pretty sure that's in, well, okay, let's go with the 95%. Let me draw a picture. I know the peak here is at 100. This one deal away is at plus and minus 20 over 7. I want to have something like this where the area in the middle is 0.95. Right? I want to be 95% sure when I make my interval that the sample mean is somewhere in there. First thing I need to do, I need to find these two cutoff values. Right? How am I going to find those, do you think?
Find the cutoff value, but you don't know.
I mean, we haven't, they're not anywhere on the, they're not written down yet. So how do we go about finding something like that?
But you do the big point or time, then call it 100,
Okay, I like what you're saying. So you're basically saying use norm inverse, right? Because we're doing the 95, then the 100, then the standard deviation is 20 over 7. The only thing is the 95 is not quite right, because remember, what I always put in is the area to the left. Right? If I look at this one, well, since the middle's 95, the two together on the sides have to be 5%. Right? So the area to the left of this one is half of 5%, so 0.025. So to get this one, I'm going to go norm inverse 0.025, 100, and 20 over 7. Right. Same thing for this one. Well, if I look at its area to the left, well, it's got the 0.025, plus it's got the whole 95 in the middle. So for the one on the right, it's going to be the same thing, norm inverse, but the area to its left is 97.5, 120 over 7. So let me punch those in just real quick. So norm inverse 0.025, 100, and 20 over 7. It's 94, and I want to do the same thing. Norm inverse 0.975, 100, 20 over 7. So if I take groups of 49 people and take their average IQ, I'm 95% sure that average IQ is going to be somewhere between 94 and 105, is what that means. So again, what that means is if I look at a group of people, size 49, then I'm 95% sure that their average IQ will be between 94 and 106. Right. I mean, individual people in that group might have IQs high or low or whatever, but if I look at the average, 95% of the time I'll get basically within 6 points of the mean. Right. So everybody happy with that? All right, so that's basically what this whole homework is about. We're going to have this normal distribution that we did last time. We'll also have two more distributions, which are, I'll tell you more about them when we get to them, but let me go ahead and tell you I think it's just t-dist, isn't it? Yeah. There's t-dist for the t-distribution, and then there's one called the chi-square distribution, which is chi-square dist. And same thing, t-inverse and chi-square inverse. So, but other than the distribution changing a little bit, it's just going to be that same thing over and over again that we just did. Right. Okay. Actually, let me tell you one more thing about these before I get to them. So this is, the t-dist is for the mean if you have a small sample. So we said the central limit theorem works if your sample size is at least 30. The t-distribution is whenever, okay, if I only have 15 in my sample or something, but I'm still looking for the mean, right? The chi-squared distribution is if I'm looking for either the variance or the standard deviation. We're not going to use that. All right. So let's actually jump to the homework. So find the critical value that corresponds to the confidence level. Okay, so we want to be 85% confident, so we want the middle chunk to be 85. So both the outside chunks together have to be 15. So what is one outside chunk going to be equal to? Yeah, 0.75. So I'm going to go norm inverse 0.75. And when you see a z, that tells you, well, this is the standard normal instead of it. Usually use x if you just have any random variable, but if you see the z, that tells you mean is 0, standard deviation is 1. So mean is 0, standard deviation is 1, and 1. No, not 1. I'm doing inverse. I don't have to put 1. So my z is 1.44. And it's really both plus and minus, but it looks like they just want the plus from the sound of it. So, yeah. All right. Express the confidence interval. Okay. Yeah, actually, apparently, before we're doing mean, we're doing proportions. So, so all it's wanting you to do is say, hey, this interval is actually an interval, right? It's everything bigger than 0.034 and less than 0.118. It wants you to say, okay, write that as a middle number minus an error and that middle number plus the error. So the first thing we're going to do is just, hey, what's the middle number? How would we find that? This is the easy part. Yeah, Lane. If you want to know the number right in the middle of those two, how do you find it? Yeah, add them up, divide by 2. So those together is 152. Half of that's 76. So my middle number is 0.76. Oops. And how wide is this? So from 76 down to 34 is 42. So 0.76. Oh, whoops. It's 0.076, isn't it? And then same thing for the other side, 0.076 plus 42. So, yeah. I want to recreate this same guy. So I'm just saying, okay, well, the 34, once I got the 0.76, the 34 is 76 minus 42. And then the 118 is the same thing. It's 76 plus 42. So you're supposed to kind of think about this as like, if I had to give one answer for this proportion and be 0.076, how much do I think I'm off by? Well, I'm off by 0.042 at most. So it's somewhere between that middle guy minus. And so the 42 is like the error and the 76 is like the estimate. Let's do something else along those lines. Okay, so it says in a poll, all right, sample data, in a poll, that many people thought they were vulnerable to identity theft. So we're trying to approximate we know how many people in the survey said they were vulnerable, but we want to have kind of a margin of error so we know, okay, the survey might not be exactly right. The population may be a little bigger, a little smaller. We want to know how much by. So first thing we're going to do is find out what's the proportion for the survey. So 503 people out of 999, how would I find that as like a percent or whatever? This is the easy part. $503 people out of 999, so like 50%, right? Roughly. Three decimals. All right. And now we want to find the margin of error, which I don't actually remember. I think it's PQ over N. Let me see if I. Double check real quick. Yeah, it's PQ over N is the. Yeah. All right. So the error, well, let me actually write that down instead of just saying it. So for proportions, the error is, well, it's your Z that we're going to have to look up as always. And then kind of your standard deviation type term is square root of PQ over it. Right?
What is that? Z? What?
Yeah, this is the norm inverse guy. The way they denote it is Z alpha over 2, whatever. But yeah. And then the standard deviation is that guy. So which you can, that's the way the book does it. You could do the same thing. You could go, well, since they're actually asking us for the error, let's do it that way. If you just wanted to know the interval, you could just do norm inverse. The percentage you care about, that P that you found, the 50.4 or whatever, and then square root PQ over N. But since they're actually asking for the error, let's go ahead and do what they said. So all right, so the margin of error. Okay. So for the Z part, we're doing a 95%, or sorry, a 99% interval, right? Yeah, 99% interval. So the middle chunk's 99. So both sides together are 1. So what's the area of just one side? Yeah, 0.05. Or sorry, yeah, 0.5, which would be 0.005 if you made it. Yeah. So 0.005. And then since we're just doing the Z for now, so mean 0, standard deviation 1. So that's like the Z part in the error term. And then the other part is the square root. Yeah, so P was this guy. And then Q is 1 minus P over the number we had, which was 999 people. All right, so my error is just those two guys together. And it really should be positive. Other than that. Yeah, just multiply those two numbers together. And they don't tell me how many decimals they want. You can go with 3 since that's what they wanted on the first one. Try 4. Oh, it does say 4. Dude, that thing's in the way and you can't read the directions.
Yeah.
That sucks. Okay. And then so P is between, well, the middle plus that guy and the middle minus that guy. So so that guy plus that, and that guy minus that. So the real proportion is somewhere between 46 and 54%. So 463 and 544. again, if they didn't actually ask us for the E itself, you could have, if all you cared about was just finding that interval in real life, you could have saved yourself a little bit of work. So to find the bottom, you would go norm inverse 0.005. The mean is that guy. The standard deviation is square root that guy times 1 minus that guy over 999. And that's it. Let me go ahead and copy all that as well. So there's the bottom, and do the same thing, except if I got 0.005 on the end and then 99 in the middle, that'd be 0.995 total. So you could have skipped to the end, but they wanted you to actually find the error. So